According to the National Electrical Code, specifically Article 215, Section 215.6, the EXO transformer connection on the primary side of a delta star, that is Y delta transformer, shall be grounded. The EXO connection on the primary side of a Y delta transformer provides a grounding point for the neutral of the primary. This grounding is essential for several reasons. Firstly, safety. Grounding the neutral helps protect against electric shocks and equipment damage by providing a low impedance path for fault currents. Secondly, voltage stability. Grounding the neutral helps stabilize the primary voltage by providing a reference point for the transformer. Thirdly, harmonic mitigation. Grounding the neutral can help reduce harmonic distortion on the primary side, which can improve the efficiency and reliability of the transformer. To ground the EXO connection on the primary side, a grounding conductor must be connected between the EXO terminal on the transformer and the grounding electrode system. The grounding conductor should be sized according to the requirements of Table 250.122 of the National Electrical Code. In some cases, the transformer manufacturer may provide an internal ground connection between the EXO terminal and the grounded primary winding. In such cases, no external grounding conductor is required. However, it is always recommended to verify the manufacturer's instructions for proper installation. When dealing with a 208 volts Y primary to 240 volts delta secondary transformer, understanding the grounding requirements for the EXO connection is crucial. This EXO connection serves as the grounding point for the neutral on the primary side of the Y delta transformer. Grounding the neutral is paramount for a few key reasons. Firstly, from a safety perspective, grounding the neutral creates a low impedance pathway for fault currents, which helps to mitigate the risk of electric shocks and potential equipment damage. Without proper grounding, fault currents could travel through unintended paths, posing significant hazards. Secondly, grounding the neutral provides a reference point for the transformer, thereby contributing to the stability of the primary voltage. Stable voltage levels are essential for the reliable operation of equipment connected to the transformer. Thirdly, grounding the neutral assists in reducing harmonic distortion on the primary side. Harmonics are unwanted distortions in the electrical waveform, and mitigating them improves the transformer's efficiency and overall reliability. To implement the grounding of the EXO connection, you must establish a connection between the EXO terminal on the transformer and the grounding electrode system, or GES. This is achieved by using a grounding conductor of the appropriate size. The size of the grounding conductor is determined by referring to Table 250.122 in the National Electrical Code. This table provides guidance on selecting the proper conductor size based on the rating of the overcurrent protective device in the circuit. It is important to consult the most up-to-date version of the NEC to ensure compliance with the latest regulations. Some transformer manufacturers may incorporate an internal ground connection between the EXO terminal and the grounded primary winding. In such cases, an external grounding conductor may not be necessary. However, it is crucial to verify the manufacturer's instructions to ensure proper installation. Always refer to the manufacturer's documentation to confirm whether an internal ground connection is already in place. Even if an internal connection is present, it is still a good practice to double-check the connection to the grounding electrode system to ensure it meets the NEC requirements. This proactive approach ensures that the grounding is effective and meets all safety standards. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes that are in direct contact with the earth. The grounding electrode system provides a direct connection to the earth, allowing fault currents to safely dissipate. The grounding electrode system must meet the requirements outlined in Article 250 of the NEC. This includes ensuring that the electrodes are properly installed and sized. The grounding electrode conductor connects the grounding electrode system to the equipment grounding system at the service equipment. The size of the grounding electrode conductor is determined by Table 250.66 of the NEC. The equipment grounding system provides a low impedance path for fault currents to return to the source. This system is typically comprised of equipment grounding conductors that are run with the circuit conductors. The equipment grounding conductors connect the metal enclosures of electrical equipment to the grounding electrode system. In the context of a 208 volts Y primary to 240 volts delta secondary transformer installation, several specific considerations should be taken into account. Firstly, the location of the transformer should be carefully chosen to ensure proper ventilation and accessibility for maintenance. Secondly, the transformer should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Thirdly, the transformer should be protected from overcurrents by using appropriately sized fuses or circuit breakers. Fourthly, the transformer should be properly labeled with all relevant information, such as voltage ratings, kVA rating, and impedance. Finally, the grounding system should be thoroughly tested to ensure that it is functioning correctly. A ground impedance tester can be used to verify that the grounding path is low impedance. The testing should be performed by a qualified electrician to ensure accuracy and safety. When dealing with a wide delta transformer configuration, the primary winding is connected in a Y configuration, while the secondary winding is connected in a delta configuration. This configuration is often used to step down voltage from a higher voltage level to a lower voltage level, such as from a 208 volts primary to a 240 volts secondary. The Y connection on the primary side provides a neutral point, which can be grounded to improve system stability and safety. The delta connection on the secondary side does not have a neutral point, which can be advantageous in some applications where neutral currents are undesirable. The 208 volts Y primary to 240 volts delta secondary transformer is commonly used in commercial and industrial applications to provide power to equipment that requires 240 volts. This type of transformer is often used to power motors, lighting systems, and other types of electrical loads. It is important to select a transformer that is properly sized for the intended application. The transformer's kVA rating should be greater than or equal to the total kVA load that will be connected to the secondary winding. In addition to grounding the EXO connection, there are other important safety considerations to keep in mind when installing and maintaining a 208 volts Y primary to 240 volts delta secondary transformer. Firstly, always to energize the transformer before working on it. Secondly, use appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, follow all applicable safety procedures and guidelines. Fourthly, inspect the transformer regularly for signs of damage or wear. Fifthly, keep the area around the transformer clear of obstructions. Finally, if you are not qualified to work on electrical equipment, seek the assistance of a qualified electrician. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is important to consult the NEC whenever installing or modifying electrical systems. The NEC is updated every 3 years, so it is important to use the latest edition. The NEC is available for purchase from the National Fire Protection Association, or NFPA. In addition to the NEC, there may be other applicable codes and standards that must be followed. These may include local building codes, state electrical codes, and industry standards. It is important to research and comply with all applicable codes and standards to ensure the safety and reliability of the electrical system. When working with electrical equipment, it is important to have a thorough understanding of electrical theory. This includes understanding concepts such as voltage, current, resistance, power, and impedance. It is also important to understand the principles of grounding and bonding. A solid understanding of electrical theory will help you to safely and effectively install and maintain electrical equipment. In conclusion, grounding the EXO connection on the primary side of a 208 volts Y primary to 240 volts delta secondary transformer is a critical safety measure that helps to protect against electric shock, stabilize voltage, and reduce harmonic distortion. By following the requirements of the National Electrical Code and the manufacturer's instructions, you can ensure that the transformer is installed and maintained safely and reliably. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. Remember to verify the manufacturer's instructions and local regulations for proper installation and grounding. Always to energize the transformer before commencing any work. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. Inspect the transformer regularly for any signs of damage or wear. Ensure adequate ventilation around the transformer to prevent overheating. Use appropriately sized overcurrent protection devices, such as fuses or circuit breakers. Label the transformer clearly with voltage ratings, kVA rating, and other relevant information. Test the grounding system to ensure it is functioning correctly. Use a ground impedance tester for verification. Comply with all applicable codes and standards, including the National Electrical Code and local building codes. Maintain a thorough understanding of electrical theory, including voltage, current, resistance, and impedance. Seek the assistance of a qualified electrician if you are not comfortable working with electrical equipment. Regularly inspect the transformer's connections for any signs of corrosion or loosening. Tighten connections as necessary to maintain a secure electrical pathway. Keep the area around the transformer free from obstructions to allow for easy access and proper ventilation. Document all maintenance and inspection activities to track the transformer's performance over time. By adhering to these guidelines, you can ensure the safe and reliable operation of a 208 volts Y primary to 240 volts delta secondary transformer. The grounding electrode system is a critical component of any electrical system, as it provides a path for fault currents to flow back to the source. This helps to protect people and equipment from electrical shock and damage. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes that are in direct contact with the earth. The grounding electrode system must meet the requirements outlined in Article 250 of the National Electrical Code. This includes ensuring that the electrodes are properly installed and sized. The grounding electrode conductor connects the grounding electrode system to the equipment grounding system or the service equipment. The size of the grounding electrode conductor is determined by Table 250.66 of the NEC. The equipment grounding system provides a low impedance path for fault currents to return to the source. This system is typically comprised of equipment grounding conductors that are run with the circuit conductors. The equipment grounding conductors connect the metal enclosures of electrical equipment to the grounding electrode system. The combination of the grounding electrode system and the equipment grounding system creates a comprehensive grounding network that protects against electrical hazards. It is essential to ensure that all components of the grounding system are properly installed and maintained to ensure their effectiveness. Regular inspections and testing of the grounding system are recommended to identify any potential problems and ensure that the system is functioning correctly. In addition to the grounding requirements for the EXO connection, it is also important to consider the bonding requirements for the transformer. Bonding is the process of connecting together all metal parts of the electrical system to create a low impedance path for fault currents. This helps to ensure that fault currents can quickly and safely return to the source, minimizing the risk of electric shock. The bonding requirements for transformers are outlined in Article 250 of the NEC. This includes bonding the transformer enclosure, the metal conduit, and any other metal parts of the electrical system. The bonding conductors must be sized according to Table 250.102 of the NEC. Proper bonding is essential for creating a safe and reliable electrical system. It is important to ensure that all bonding connections are properly made and that the bonding conductors are sized correctly. Regular inspections of the bonding system are recommended to identify any potential problems and ensure that the system is functioning correctly. In addition to the safety benefits, proper grounding and bonding can also improve the performance of the electrical system. By providing a low impedance path for fault currents, grounding and bonding can help to reduce voltage drops and improve the stability of the electrical system. This can lead to improved performance of electrical equipment and reduced energy consumption. Proper grounding and bonding are essential for creating a safe, reliable, and efficient electrical system. The NEC provides comprehensive guidance on the requirements for grounding and bonding. It is important to consult the NEC and follow all applicable requirements when installing and maintaining electrical systems. Always seek the assistance of a qualified electrician if you have any questions or concerns about electrical safety.